All right, so finishing up the probability of not white. The next one is probability of green. Well, the total green I have is 0, so there is a 0% chance that I'll get green. The next one was probability of blue or white. That means I can get either one, it doesn't matter. So I needed to get the total of those together. So there were 4 blue and 1 white. So that was a total of 5 over 8. Now when I divide, I get 0.625. To change it to a percent, move it 2 places over, and I get 62.5%. Okay? Now, question 17 says if you spin the spinner 120 times, about how many times would you expect to spin blue? Well, my blue was 1/2, so I'm going to use that. And I'm going to spin a total of 120. So that leaves me x, cross multiply. Go ahead and multiply. Solve by dividing by 2. And so x would be 60. Number 18 says, if you spin the spinner 120 times, about how many times would you expect to spin white? Well, if we look back, our not white was 7 over 8, so that told me we had 1 white. So my fraction is 1/8 is equal to x over 120. Cross multiply, so we get 1 times 120 is equal to 8x. 1 times 120 is 120. Divide by 8. So 120 divided by 8 is 15. So 18 should be 15. 19 says, what is the theoretical probability of tossing a coin and landing on heads? Okay, there are 2 outcomes when tossing a coin. It's heads or tails. There's only 1 chance of getting a heads. So it's 1/2. It did ask for that as a percent. So I want to divide that and get 0.5, change it to a percent, and I would get 50%. Number 20 said, use the fundamental counting theorem. If you'll remember, the fundamental counting theorem was just multiplying all of our possible choices. It said, I wanted to order a birthday cake. I could choose between white chocolate or yellow. So there were 3. I could either get cream or strawberry filling. So that was 2. I could get white or buttercream frosting. So that was 2 types of frosting. And then I have a 1/4, a 1/2, or a full sheet cake. So that was 3 different sizes. So now I'm going to multiply those. 3 times 2 is 6, times 2 is 12, 12 times 3 is 36. So there's 36 different combinations. Number 21, the order for purchasing school apparel allows you to select from a short sleeve t-shirt, a long sleeve t-shirt, or a sweatshirt. So there's 3 types of shirts. It comes in a small, medium, large, or extra large, so that was 4. And I have 2 colors, orange or maroon. So now I'm going to multiply. 3 times 4 is 12. 12 times 2 is 24. Now, 22. It says your wallet contains the following bills. 3 $20 bills, 1 $10 bill, 4 $5 bills, and 2 $1 bills. Assume all pulls are random and the bill is replaced before each pull. So I want the probability of pulling a 5 and then a 1. Okay, so how many probabilities of pulling a 5? There are 4 $5 bills, so that was 4 over a total of 10. There was 10 different bills there, times the probability of pulling a 1. There were 2 1s, and because I did replace, it's still 2 over 10. So now when I multiply, I get 8 over 100. I need to reduce that. 4 will go into both. So I get 2 over 25 as my answer. Okay. Number 23 says, find the probability of pulling a $20 bill. So there were 3 $20 bills times not pulling a 10. There was one $10 bill, so there's 9 of them that is not. So that would be 9 over 100, or 9 over 10. When I multiply, I get 27 over 100, and that one will not reduce, so that is my fraction. Okay, number 24, it said there are 2 blue, 5 red, 1 orange, and 2 green pencils in a jar on the teacher's desk. Students randomly choose a pencil from the jar and do not replace it. What is the probability the student will choose an orange pencil and then a blue pencil? Well, I have a total of 10 pencils. One of those is orange, so 1 out of 10. I am not replacing, so I know that I am going down 1. Now I want a blue pencil, so that would be 2. When I multiply, I get 2 over 90. I can reduce by 2, and I get 1 over 45. Okay, we have a table that represents choices of snack foods from a group of students at a computer camp. Use the data in the table to answer the next 2 questions. So it says, what is the probability that one student chooses a fruit and another chooses chips? Well, first of all, total students I have is 24. 8 of those chose fruit. Okay, so I'm going to times that by another one choosing chips. Well, that's going to be 6 over. Because it's food, we're not going to return it. So we're going to say 6 over 23. So when I multiply here, I get 48 over 552. It looks like a 8 will go into both. So this will be 6 over 69. 3 will go into both. So my answer is 2 over 23. And that was number 25. Now 26 says, what's the probability of one choosing carrots, not replacing, and then choosing granola? Well, a carrot is 4 out of 24. And I'm not replacing. And then I want a granola. Granola would be 2 out of 23. I'm going to multiply, so I get 8 out of 552. I'm going to divide both sides by 8, and I get 1 over 69. Okay, the next one says Susanna was looking at a menu below for lunch at a summer camp. It says if Susanna chooses only one item from each category, how many different combinations could she have for lunch? So on 27 for that combination, I want the main dishes times sides times drinks. Well, it looks like I have 3 main dishes, 2 sides, and 3 drinks. So when I multiply those, 3 times 2 is 6, 6 times 3 is 18. So there's 18 different combinations. Number 28, we have a dice and a spinner. They want to know what the probability of a 3 and a red is. These are independent of each other, so I'm going to multiply them. So first of all, to get a 3 on a dice is 1 out of 6. A red on the spinner is, I'm counting the red, it's 3 out of 8. Multiply, I get 3 out of 48. Reduce down by 3, and I get 1 out of 16. Okay. 29, I want the probability of an even number and not blue. So an even number on a dice is 2, 4, 6, so that's 3 out of 6, which is 1/2. Not blue, there were 4 blue, there was a total of 8, so 4 of them are not blue, so that's 1/2. And when I do multiply those, I get 1/4. Now, if you need it to multiply up here before without reducing, you could have. That would have been 12 over 48, reduced down by 12, and you still would have gotten 1/4. Okay. Number 30 says there are 3 red marbles, 4 green marbles, 2 yellow marbles, and 5 blue marbles in a bag. One is drawn. It is not replaced. What is the probability? I want the probability of a blue and then a green. Okay. Because we're not replacing, okay, this is dependent, so it's going to change. My blue is 5 over a total of 9, 11, 14 times a green, and that's going to be 4 over 13, multiply reduce, so I get 10 over 91. 31 says a probability of a yellow and then a red. My yellow is 2 out of 14, and then my red is 3 out of 13 because I did not replace. So I have 6 over 182. That's divisible by 2, so I get 3 over 91. Okay, 32. I want the probability of 2 yellow. So I want a yellow, then a yellow. So the first one is 2 out of 14. Now I've got to pretend like I got a yellow, so my next one is just 1 out of 13. So I get 3 over 182, and that one will not reduce. So I have to leave it as 3 over 182. Okay. 33 says circle all the expressions that are equivalent to 10 to the negative 3. Remember, the negative 3 here means that I'm going to flip. I'm going to take the reciprocal. So that becomes 1 and 10 to the third power. We know 10 to the third power, if I expand that, is 10 times 10 times 10, which is on the bottom, so it's going to stay on the bottom. If I also multiply, it's 1 out of 1,000. And now if I divide that to a decimal, it is 0.001. So you would have to pick 3. This one, and this one was on your paper. 34 said arrange the 3 numbers in order from least to greatest. We have 4.4 times 10 to the negative 2. We have 4.2 times 10 to the 1. And we have 5.121 times 10 to the negative 3. Well, if you remember, the negatives moves this decimal out 3 places. This one would move it 2. So this one would be smallest. So if I needed to do that, 0.005121, this would become 42. And this would be 0.044. So if I'm comparing between 4 and 0, this is the smallest. So 5.121 times 10 to the negative 3 is the smallest. 4.4 times 10 to the negative 2 is the second smallest. And 4.2 times 10 to the 1 is the third smallest. So that's the largest one. And 35 says circle all the values in the box that are perfect squares. Well, first of all, what you need to remember are your perfect squares. 400 is 20 squared. 361 is 19. 190, if you did that on a calculator, it comes out to 13.7. So that is not a perfect square. 60 is 7.7. So that is not a perfect square. 324 is a perfect square of 18. 256 is a perfect square of 16. 50, if you take the square root of 50, you get 7.07. That is not. And 5 is 2.2, and that is not. So the only ones that were perfect squares is 400, 361, 324, and 256.